Welcome, everyone, to the Deep Dive. This is part of the Loop AI podcast series from Loop AI Labs, which you can find at loop.ai.
Glad to be here.
So today, we're going to unpack something really critical for anyone in enterprise AI. We're talking about why those big, sophisticated R-RAID systems...
Retrieval augmented generation.
Right. Why they are fundamentally doomed to fail once you try to scale them. So, let's get into it. The shocking math that shows why these systems just don't hold up.
Yeah, and what's so fascinating is that this isn't some kind of software bug. It's not a coding error.
It's not something you can just patch.
Exactly. It's a problem of geometry. We call it semantic collapse. Every single document you feed into a RAG system, it gets turned into a high-dimensional vector.
Embedding.
And embedding, right.
Yeah.
But once you get past a certain point, maybe around 10,000 documents, that whole vector space it stops being a useful map of meaning.
Okay, so if I'm picturing my data like a giant library, but in, say, 1,000 dimensions, why does it break? What's actually happening?
It's the classic curse of dimensionality.
Okay.
Think about it like this. You're trying to find one specific grain of sand on a vast, perfectly flat beach. In that high-dimensional space, the math shows that something like 99.9% of your data points, your documents, they all end up on the outer surface of this hypersphere. So they all become basically equidistant from any question you ask.
So your search becomes a lottery. It can't tell what's actually relevant because everything looks relevant.
It's a very noisy lottery. That's a perfect way to put it.
And the empirical data on this is, it's brutal. Stanford's research found a huge hit to precision.
It's a cliff.
A cliff, yeah.
Yep.
Between 10,000 and 50,000 documents, they documented an 87% drop in precision. So you're adding more context, thinking you're making it smarter.
And you're actually making hallucination worse.
Much worse. So what does that look like in the real world?
Well, it's serious. You see legal AI systems that start citing the wrong precedents, or medical rags that mix up patient information because the system genuinely cannot tell document A from document B anymore.
So wait, what about all the solutions we hear about? Things like, re-ranking or better chunking strategies.
Those are just Band-Aids. They really are. They might delay the inevitable collapse, but they don't fix the underlying geometric problem.
Because the space itself is noisy.
The space is chaotic. No amount of filtering on top is going to make that retrieval reliable at scale.
Okay, so if retrieval itself is the problem, that leaves a pretty massive hole. How do we fill it?
Well, that's where the pivot comes in. The solution isn't better retrieval. It's avoiding that noisy retrieval process altogether.
And this is where LoopQ comes in.
Exactly. The LoopQ cognitive platform moves completely beyond a RAG. So instead of using a generic LLM to search against a messy vector database, we use LoopQ to train a custom small language model, an SLM, from scratch.
Directly on the client's own data.
Directly on their proprietary data. So the knowledge isn't being looked up from the outside.
It's being ingested, internalized.
It's part of the model's core understanding. This custom training focuses the SLM semantics only on that specific use case. The result is just ultra-high accuracy.
Because its whole world is just that data.
Right, and it means you minimize hallucinations, and you can run these models on-prem or at the edge, which gives you low latency and critically full data sovereignty.
And this isn't just a clever workaround, is it? There's some real theory backing this up. You mentioned the semantic characterization theorem.
I did, yeah. It's a bit deep, but it essentially implies that if you constrain a model correctly, its internal black box of knowledge, its latent space, actually collapses into a finite, predictable structure.
So it proves that you can get tameable, structured semantics.
Yes, but only if you train the model directly on the knowledge instead of asking it to find its way through that chaotic high-dimensional noise of vector search.
And this is all managed through the Loop AI Agents Orchestra platform.
Correct. Orchestra is the control center for this whole life cycle. It lets you deploy these agents, hot swap models instantly, and you can combine a custom SLM from LoopQ with a public LLM if you need to.
Giving you full control.
Full enterprise sovereignty. And you're not locked into any single vendor. You use the best tool for each part of the job.
So when you boil it all down, semantic collapse is a mathematical certainty for any R-RAID system at scale.
It is.
But the solution is right there. Train the intelligence directly on your data.
You move from a chaotic lottery to focused, custom-built semantics.
Yeah.
And that's how you get precision and reliability for mission-critical work.
A fantastic summary. Thank you for joining us on this deep dive into the geometry of meaning. We invite all of you to listen to the next episode of our series, which will be made available on X.
And you can check out the Loop AI Agents Orchestra platform for building your own digital workforce over at loop.ai.